Hello, welcome to Numeristical. We are continuing our series on Major League Baseball prediction. We are now in the 9th video of this series. In the last video, we added features related to the bullpen to our model, and we were able to show a pretty significant improvement. We went from about 70 basis points off the Las Vegas probabilities to about 40 basis points off the Las Vegas probabilities in terms of our performance in log loss on a test set, where the test set was the 2021 and 2022 seasons. So we are making progress. We are getting closer and closer. We also did some analysis to show that just getting close to or even exceeding the Las Vegas model might not be enough to actually be able to make successful bets on the money line. That we need to not only do better than the Las Vegas model, but more precisely, we had to do better on the games where we disagreed. So we need to disagree from Las Vegas and be right when we disagree. And we showed that that's actually quite a considerable challenge. Going forward, we decided the next step should be to get individual batter data so that when we come up with the offensive statistics for a team, the features about how good the offense is in this game, the hitting, that it would reflect the actual hitters who were in the lineup that day rather than just the team's past performance. So we were worried about situations where perhaps a star player gets hurt or a star player is resting for that particular game. And so the aggregated past performance of the team hitting might not really be reflective of what the team hitting is going to look like for this particular game. So in this video, we're going to show how to get the raw batting data and then process it to come up with some features that are hitting related features, but that reflect the actual lineup that's in the game that day. So before we get to it though, I'd like to again ask you if you could please like this video and subscribe to the channel. It's really helpful to me for keeping this going. And with that said, let's go to the notebook. Okay, so as we said, currently the model averages the recent team hitting performance. It does not account for the particular players who are in the lineup that day. So if a key hitter is resting, injured, got traded, etc., that will not be reflected in our team statistics. So our team statistics will aggregate the performance where that hitter was still in the lineup. So to begin doing this, the first thing we need to do is to scrape the raw batter data. So this is going to be very similar to how we got the pitching data. I'm going to try to go through it a little bit more quickly this time since it's very similar to what we already did before. So do all our imports, and like a good middle-aged Mets fan and a Seinfeld fan, let's look at Keith Hernandez's statistics and his page. So if you remember the way RetroSheet is organized, you have this URL for the hitter, which shows, which has a particular format. It's this retrosheet.org, boxes, etc. It has an H because that's the first letter of Keith Hernandez's last name. It has a P, meaning that he's a player, not a manager, and then it has the ID.htm. From that, we go to kind of his homepage. His homepage has season by season statistics, which is not exactly what we want. Instead, what we want is to go into these daily games. And if you see each of those daily games has a particular URL. So what we want to do is take Keith Hernandez, go to this page, grab all these season by season URLs, and then if we click on one of these, you can see now this page has what we want, which is the game level statistics. So you can see that this is his 1986 season, and here's every game he played. And he ended the season with a .310 batting average. So, how are we going to get this? So, we want to do a few things. One, we want to have a function. We're going to do this. It's going to be a very similar process to what we did before with the pitchers. We've got one function which you give the ID, and it's going to grab all the season-related links. So let's do that. So you see now we've got a link for each of Keith Hernandez's seasons. Now we could click on one, let's say his 1986 season, and we get this page that we were just looking at. So now we want to go to each of these links and grab that particular season. So we're going to have, again, a function called get season batting data, which is going to take that URL and spit out, gather all the statistics for each game, process it nicely. Again, very similar format to what we did before, so I'm not going to go through it in detail. This notebook will be available on our repo. And let's just check to make sure this is working as we expect. So if I grab this URL from 1986 from above, run this function, wait a few seconds, we see that we have game by game for 1986, Keith Hernandez's various statistics. One thing I want to point out here is we have the position over here, so we're going to use that position a little later, but I want to point out that that's one place where we get the position that the person played. So we could scroll down to the end of this. You can see he's got 140 something games. Now we want a function that gets all the data for a particular batter, so it's going to be very simple. It's going to get all the links. It's going to create a blank data frame. It's going to go through each of the links and get the data frame for that particular season and concatenate them all together and return one big data frame. So again, we could do this. We got to wait a few seconds because now it's going to have to churn through each of his seasons. So we'll let that run for a few seconds to go through. Again, I put in sleeping in each of these functions so that it waits a second or so between going through things. You could probably make it a little faster if you wanted to. But again, you got to be careful. You don't want these sites to block you if you go too fast. Okay, so that's done. Let's just look at the head. So again, you can see these are the first 5 games of his career back in 1974. Now, what do we want to do? Well, we want to do this for every single batter that we have in our data set. So we got to read in our current data frame. All right. And now if we scroll over here, we just want to check the columns. So if you scroll all the way over here, you start seeing, see batter 1, visitor, their name and their ID. Now, one thing to point out is somewhere I messed up name and ID. So the column that says name is actually the ID, and the column that says ID is actually the name. And I had made this mistake, I'd fixed it, but then I think I somehow copied one of the wrong versions. So I propagated this error. I don't want to try to go back and fix this right now, but it's just a simple thing to keep straight, that actually the name is going to refer to the ID and the ID is going to refer to the name. But you see the convention here. It starts with visiting. You have batter 1, batter 2, batter 3, and it puts their position there, their name, and their ID. For each of the 9 batters, so the numbers are for the position in the batting order. 1 through 9 for the visiting team, 1 through 9 for the home team. So you've got the 18 batters in the starting lineup. So we want to get all the batters in our lineup. So we're just going to go through 1 to 9, go through home and visitor, get that column name, batter, number, plus name, plus suffix. We want the ID, but it's called name, so we're using name. And just put them all together. So we've got 6,459 people who have appeared in a starting lineup between 1980 and 2022. And here are the first 10. This is just in order of how they appear. So these are all folks from 1980. Ricky Henderson, noticeably. Okay, so now we've got all the batters. We've got this function that grabs the data and gets the entire career game level for that batter. So we're just going to go through everyone. Now, I'm not going to go through everyone. This is, again, another thing that will take quite a bit of time, especially as you're putting in sleeping to stop websites from blocking you. So I'm just going to demonstrate it for the first 2. So we run it. It gets the first one. Now remember, I put in about a second sleep, so it's about 1 second per season, maybe a little more that it's going to take to download a particular batter. So, and here you see it's doing the second one. And that's what it'll do. And it'll save each of these to a file. So now we'll have a CSV file for every single batter that appeared in a starting lineup in the history of our data set. So that's getting the raw data. Once you've done all that, we're going to go over to the second notebook, which is adding and processing the batter data. So now we've got files that have the career game level statistics for each batter. So again, we're going to take the same approach we've been taking before as we did for the pitchers. We're going to, for each batter, we're going to load in their career, and we're going to process the trailing history. So for each game, we're going to summarize the statistics in their previous N games, where N might be 30, 50, 100, whatever numbers we choose. We're going to average those statistics and thereby link to each game that player started, what were their sort of trailing statistics coming into that game. So then after we do that, we're gonna do that for each batter. So we'll have this data frame that says, for this particular game, here are the features we should use for you when you started that game. Then we've got to go through our main data frame that has all the games that we want to predict and add those columns into our data frame to say, okay, here's a particular game in our data set. Here's who is batting first. Let's find that person in our player level data. Here was that person's statistics right before that game. Let's put them in. Those are our features that we're going to use for that model. And then actually what we're going to want to do is we may want to derive actually team level averages. So we'll have for each of these 9 players on each team, so for 18 different players, we'll have a variety of statistics about that player. That's going to be a lot of information, and it's not necessarily organized in the best way, because it's going to say your leadoff hitter, what were their statistics? Your second hitter, what were their statistics? So we might want to average across each team somehow and get, again, sort of team statistics that reflect the particular lineup that started that game. So how are we going to do this? We're going to read in our data frame again. And I'm not going to run this notebook live because this one actually takes a long time to run. It's actually still running a little bit in the background because I wanted to rerun it once more before sending it out to you folks. But there's a few wrinkles compared to how we did this with the pitchers. So when we aggregated the pitchers' past performance, if you remember, we used some default values to smooth out players with little to no history. So if you had a pitcher and it's their first game, or maybe it's their third game, so they have very few innings pitched, what we did was we said if they have less than a certain amount of innings pitched, we're going to add in more innings pitched and add in some number of hits, runs, etc., that sort of reflect a kind of a mediocre, not so good pitcher. So the idea was assume people are not very good until they have enough history that proves that they're good. Because you don't want a pitcher who they pitch 2 scoreless innings, get taken out, and now the model says, oh, this is the best pitcher ever. They've got, a 0 ERA. You want to say, okay, I still don't know about this pitcher. Their first 2 innings were pretty good. I'll average in 2 pretty good innings with the rest of my not so good data. So we wanted to do the same thing with batters. But this is a little more complicated because different positions have different sort of typical hitting capabilities. Now, most notably, the pitchers in the National League, which in most of this data, the pitchers in the National League were still hitting. This is something that changed just in 2022. And pitchers are generally bad hitters. Shohei Ohtani aside, pitchers tend to be very bad hitters. And the reason why is they focused on pitching. It's a different skill set. They focused on pitching. The pitching is what has got them into the major leagues in their career. There's no reason to expect that they should also have this other completely specialized skill, which is hitting, have that at a major league elite level. So if you look historically, pitchers in the National League, they bat around, 100, 125, something like that, very low batting average. This is also true to a lesser extent with shortstops and catchers. Maybe you would even say second base and third baseman, also slightly weaker hitters. Um, so, and the reason why, again, is catcher and shortstop are two positions where defense is really important. So you need to get someone in those positions who's a great fielder, so you're willing to accept a slightly poorer hitter if their fielding is good. Now, the idea here is if we were to ignore position and say, okay, I've got the hitter, they've got some statistics, we've got 20 games of history on this hitter. I'm going to just average in, a 250 batting average, which is not that great. The problem is if they're a pitcher, averaging in a 250 batting average is actually very good. We don't expect these pitchers to hit 250. And to a similar degree, to a lesser degree, catchers and shortstops also, we don't expect to be hitting 250. That would actually be a pretty good catcher that hits 250. So we have to be a little bit more clever, and we have to come up with separate defaults for different positions. So the way I handle this, and this is by no means perfect, but it's just, again, to try to mitigate some of this, is I came up with different defaults for the different positions. So I've got for the pitcher, I put them as a 100 batting average, 150 on base percentage. Shortstops, I said hit about 205. And I looked at some data to roughly characterize these. I could have done a little bit more precisely, but I wanted to just get something rough and quick. So for second base and third baseman, I assume they hit about 240. And for everybody else, I assume they hit 255. And with the other numbers, on base percentage, slugging, all these other things, similarly progress in this way. And so now, when I go through this main data frame, this main function, so this is the function where I go through a hitter's history, and for every one of their games, I say, here are the statistics I want to use for this hitter going into this game that I'm going to use to try to predict this particular game, and it's going to be based on the history before that. So this way I can make, when I sort of smooth out the cases where we don't have a lot of history, I'm factoring in what position they play. So that if they're a pitcher and we don't have much statistics on them, we say this guy's probably going to hit 100. They're probably not a very good hitter. But if we see right fielder, we assume, hey, they're probably a pretty good hitter because outfielders tend to be better hitters. So here's how our function's going to work. You give me a pitcher ID, and you give me this dictionary of defaults that I find up here. And I'm going to load in the file. I'm going to figure out what position they are. I got to do a little bit of case handling. Sometimes if somebody was primarily a pinch hitter and then they came and played first base, we have to do a little bit of handling of that. But essentially, we're going to do the same thing we did for pitchers. We're going to have a window size. I put 4 window sizes here. And we're going to say, for these raw columns, for each window size, first thing we're going to do is aggregate these raw columns. So at-bats, hits, walks, doubles, triples, homers, hit by pitch, strikeouts, stolen bases, caught stealing. First we'll aggregate this. Then we're going to get some of these defaults. So you'll see some of these defaults are based on this dictionary that we provided. And then we're going to just give variables to the names of the columns. So we do this to reflect that there's different window sizes, because we're going to do this once for every window size. So we just give a little naming of columns. And then these are the columns that we created above by aggregation. And these are sort of their nicknames, so to speak. Then we're going to give names to the columns that we're about to create over here. And then we're going to create those columns. And each of these things that we create follows the same format. We check We check whether they have enough at bats or plate appearances or whatever is the denominator. We check that it's big enough. If it's not big enough, we add in some, and we add in some statistics to the numerator to compensate for that. So we're going to calculate batting average, slugging, on-base percentage, this modified slugging, their strikeout frequency, and then for on-base plus slugging, I just add, again, the two, the on-base and the slugging. And then I come up with the indicator for the game, this date doubleheader. I set it as the index. And then this is just some exception handling that we can look at in a minute. But again, same strategy. Now, after this is done, for every game, I will have, rather for every batter, I will now have a data frame where I can look up by index a particular game and grab that hitter statistics. So I define this function, and I get, again, all the batter IDs in my data frame, same way I did it before. And now I iterate through all of these batters. And you'll see some of the exception handling coming up. So sometimes when I go to process the data frame, I get like an empty data frame. And this typically happens, we'll see, in situations with pitchers who might have not actually batted in the game. So the situation is, let's say a batter starts a game and pitcher starts the game, they're batting ninth, they only last one inning and then they get pulled. They never actually got to hit. And maybe they never pitched another game in the National League. Maybe they got traded to the American League after that or something like that. And so they actually have no batting data, even though they were the starting batter for a particular game. Now, it's kind of a rare situation, but it, over the course of however many decades of baseball history we have, it's happened a few times. So that's what's happening over here. So you see it happens, a dozen or so times. But we run this, now we've got this big batter data dictionary. Now we have an easy way to look up for any batter, for any game. We can get what statistics we should use to represent their recent performance that we can use to predict the following game. So next we go through, this is again just some bookkeeping. I'm going to create a dictionary, and these are all the new columns we're going to create in our data frame. And I'm going to first hold them in a dictionary. I'm going to go through the data frame, fill up the vectors in this dictionary. So these are all NumPy arrays. I start them out. Previously I'd started things with zeros, but I decided it's a little safer to start them with missing values. And this way we know something doesn't get filled in, and we know that it was not, it was a missing value versus a zero. It's important to kind of distinguish those in this case. Then what am I going to do? This is a little helper function. This says, I've got a row in my data frame. Who are the 18 players I need to look up? And it's these 18 players. It's very simple. And now here's the main loop where we iterate through our main data frame. Data frame that's all the games that we're trying to predict and learn from. We're going to go through each one. We're going to grab each batter, so you get the current batter, and then again do some exception handling. Basically check that we have a data frame, that it's not none, that it has actual data in it, more than one row. We look up the game. If we don't find the game, so if we don't find the game and they have data, what that really means is they started that game in the lineup, but they didn't actually hit that game for the reasons I described before. So when that happens, what we're going to do is look at the previous game, and if they don't have a previous game, we're going to use actually the next game. So just a little bit of handling. What happens in these corner cases where they started the game but didn't actually pitch, so we don't have an entry for them in that game. We're just going to handle those. That's what this except block does. And so forth. And then we go through And here's where we actually assign the values to our dictionary, and the rest is exception handling. And then we go through, and you can see it's pretty verbose. It says, when here's a batter, we didn't find a game on this date, so we're going to use their statistics for this date. And sometimes it just says, hey, we didn't find anything for that pitcher, for that player. So again, these are cases, two different cases. One case is where we actually have no career batting data for that pitcher at all. And other cases where we have some data for that batter, but we don't have that particular game. And if we don't have that game, we just use a nearby game, and it all makes sense. We're not doing any cheating here. So we go through all 96,000 rows for this. And you see, you know, we're missing a few, but it's quite few that we're missing over, you know, given that we're looking at 96,000 games and 18 batters per game, right? Then we add them into the data frame. This warning is just, you know, if you do a lot of messing around with your data frame, it gets fragmented. And if you just call this line, it kind of fixes the problem. And now let's look at our new column. So let's now look at what's missing. Where are the cases where we didn't actually fill in the values? This is why I want to leave things as not a number, so that we could quickly find out how often were we not able to fill in a particular value. And you see that, you know, for batting average 30, we've got once we couldn't get the 8th place hitter, and then 32 times we couldn't get the 9th place hitter. So most of these mistakes that we had before, where it said I couldn't find something, most of them were players that were batting 9th and presumably were pitchers. And you see it's not that many. There's 33 cases, and you see it's the same pattern for all the variables. So there were 33 times where we didn't have a particular hitter, and 32 out of those 33 times it was the 9th place hitter. So just to simplify, what I'm just going to do is I'm just going to fill in those values with the default value. So whatever column was here, I'm going to just fill in the default value for that position. I'm going to put in the default value for a pitcher. So even though one of these wasn't a pitcher, again, there's one 8th place 8th hitter that we didn't find. I don't want to stress too much about it. It's 32 games overall, 32 values overall. I'm just going to fill in the pitcher's value for all of them to make my life easy. Okay, so we're basically done here. We've got now all of these statistics for each of those 18 players in the lineups. The last thing I want to do is create some summary features. So essentially, for each of these 6, these are the 6 main things that we're capturing about each hitter. Again, over different window sizes. I'm going to do a few things. One is I'm just going to average them across all 9 positions. So have for the home team and for the visiting team, let's average across the 9 hitters starting in the lineup, each of these 6 statistics for each of the window sizes. And then I'm going to do a couple other things. I'm going to also look at the first 8 hitters, just in case there's any screwiness with that 9th place hitter. Maybe it's better, maybe there's be some value in just looking at the top 8. Similarly, I'm also going to do a weighted average. Now I came up with these weights up here, and I did something, I wouldn't call it sophisticated, but it's something intentional, where I tried to go through and estimate. So this is trying to account for the fact that the batters at the top of the lineup will bat a little bit more than the batters at the bottom of the lineup. So, you know, if you've got better hitters at the top and worse hitters at the bottom, that might be better than having the same exact hitter across your lineup, because those early hitters will be able to hit more. So I came up with these weights. When there's 9 hitters, here's roughly what I think the weight should be. when there's only 8 hitters, use the same weights and renormalize them to sum to 1. And then I came up with these features. So these features are now going to say lineup 9, here are the averages, lineup 8, meaning just for the first 8 hitters in the lineup, here are the averages. Sometimes I'll put a underscore W to indicate that it's weighted, and we add those in. And then we just save our data frame. So that's all we're going to do today. In the next video, we are going to add these. We're going to add these features to the model, see how much performance bump we get, and then decide on our next moves from there. So thanks very much for watching. Again, if you could like the video and subscribe to the channel, it would really help me out. And that's all I have. Again, next video coming up, we'll add these features to the model, see how much of a bump we get. And then I believe after that, what I'll do is start trying to use some of this to predict the runs scored and predict the over-under and start doing some analysis in that vein. So I hope you'll continue to watch these videos. Thank you very much for joining me today, and have a great day.